And when I learned about Rust, the fact that I could write this extremely high level code, but have these low level guarantees, just like really, really made me excited.
Welcome, Robert. I want to talk about three things today. Isograph, what it is and what problem it solves for people, and why and how you built it in List. So what is Isograph? What problem does it solve for web developers?
All right, John, thank you so much for having me on Coding Chats. I'm honestly really excited. Like, I love talking about Isograph. I've been working on it for several years now. So yeah, let's get started. So Isograph is an compiler-driven, opinionated framework that makes it easy to build performant and stable data-driven apps. So in particular, right now it's focused on GraphQL and React and web, but those are all implementation details. So you can think of it as a way to build data-driven apps. So the problem right now with the way web development is done is that you need to fetch data as soon as possible, sort of in one go. And usually that means sort of at the outer layer. And then that data gets consumed by a bunch of components that are maybe several hops away. So for example, like the blog title subcomponent, there might be a blog component, a Chrome, another blah, blah, blah. And you have to pass it down. So one, there's just a lot of boilerplate going on. Two, there's no guarantee that if you fetch something in a query, it actually ends up getting used. And so in particular, if you imagine that you are given a ticket by your PM to stop using some field in some subcomponent, well, it's easy to stop using it, but then you go back to the query declaration and you prepare to stop removing it. But you really can't without doing a whole bunch of research, so sort of tracing where that data flows and trying to understand, like, is it used by any other subcomponent? And in particular, this problem is a lot worse than it sounds. If that subcomponent is used across multiple screens, there's multiple queries that you have to worry about. And if that data flows through something like Redux or something where it doesn't flow directly to the subcomponent. And if it flows in a way that isn't tracked by the type system, for example, through JSON.stringify, or if everything is optional, but you actually expect it to be there, or worse, if you're actually modifying sort of a REST endpoint where now you have to worry about multiple versions of your app, whether any subcomponent, any version of your app is using that field. So as a result, sort of over time, apps become sort of bloated. They end up fetching more data than they end up using, or end up provably using at least. And we have sort of a lot of not good options in this case. For one thing, we can continue to try to fetch all the data up front. Good for performance, maybe a little bit harder for stability. It's easy to ship a broken app. Two, we can try to, we can just say that we're okay with overfetching, in which case maybe the app is a little bit slower than we need. Or three, we can sort of have every subcomponent, or at least certain subcomponents, fetch the data that they need. The problem with that is that sort of architects in a network waterfall. So you might have like the blog component that's part of the user page, and only when we start to render the blog component do we actually kickstart the request for that. That's nice because if there's some logic that prevents the blog from being shown, maybe it's in a modal, or there's some state that causes it to be shown or not, well, then we won't fetch the data we don't need, right? Or if somebody changes some logic such that the blog is not shown, we won't fetch that data. But of course, there's a network waterfall, so the data that we show to the user is shown later than it otherwise would. So just in general, like, web development suffers from this inability to precisely say what you need. And I would, I guess, analogize this a little bit to imagine if every single dependency in your package JSON or your cargo TOML or whatever carried a runtime cost, and there were not like 20 of them, there were 1,000 of them, and you had no way to automatically determine whether each of those was actually used. Well, that would be a bit of a nightmare, and somebody would try to come up with a solution for that. And that's essentially what we're doing here. All those dependencies are things that are fetched up front, have a runtime cost because they have to be downloaded, and take some time to calculate on the server. And then we have no good way to determine whether on a given screen they're actually used. Okay, so what is Isograph and how does Isograph solve this general problem? In Isograph, developers write their apps using essentially a tree of functions from some graph data to an arbitrary value. We're going to call these client fields. And that graph data includes stuff like the full name field on a user or their avatar or what have you. And this is written in a way that's essentially statically analyzable. And then there's a compiler that scans your code base and starts from a root, let's say sort of the user detail page, and then traverses that user detail page. Okay, it accesses the avatar, it accesses the blog detail, whatever, and then generates a query for exactly the server fields that are used on a given screen at a given time. And that's great because it means that if you stop using a field in some subcomponent, well, if it's not used by any other subcomponent, it will not show up in the query. And if it's used by any other subcomponent or somebody lands a change at the same time or whatever, it's used across multiple screens, like no problem. Like it's all calculated based on the state of the code base. And this essentially allows developers to focus on just one file at a time and not keep sort of the overall structure or the overall project in their head at once. Because at some scale, you just can't keep everything in your head, especially if you come back after a week of vacation and sort of the interns have made changes. Now you don't know how everything works. You don't really know whether those invariants that you were trying to uphold are still being upheld, or you're dropping into a project, whatever. Like there's lots of situations where you don't understand the project, and that leads to a whole lot of manual testing or uncertainty or what have you. And with Isograph, all of that is removed. You make the changes you need, and then a compiler runs, and it generates a whole bunch of files, like a lot more than you would think is reasonable. They can include the query for that fetches the data that you happen to need. It includes a bunch of files that will connect your components, pass data around. It includes a bunch of types, and these types will, will give you everything is statically typed without you providing any static types. So that's sort of the gist of what Isograph does. It's a really good way now to build apps that are stable and scale to lots of developers touching the same code.
Well, that sounds very useful. I'm particularly, thinking of more data. A lot of work I've done in the last couple of years has focused around privacy. And obviously, the less data that we're pushing around, the less data we're sharing, the less data we're pushing back over the web, the more compliant you are with privacy laws and the less risk you're going to have of breaching them. So that sounds really useful. We talk a lot in software engineering about opinionated. What does it mean that Isograph is opinionated?
I think Isograph is opinionated sort of in two ways. One is we want to encourage you to use the building blocks that will be the most performant and allow you to be to fall into a happy, like the pit of success. That's sort of the phrase I guess people use. And I don't know what opinionated really means. I don't know. The reason I use it is because when you write an Isograph app, It doesn't look like a data fetching framework where, sure, you just fetch the data using XYZ library and then everything else is the same. In Isograph, the building blocks that you use are functions from some graph data to some arbitrary value, and it's all intermediated by Isograph, which is to say you have like the user detail page, maybe it selects the user avatar, and that itself is another client field, so a function from some graph data to an arbitrary value, in this case to a React component. And you don't, for example, import the avatar. You don't pass any data to the avatar. And all of that is actually ends up being quite important because it's all Isograph that's doing that connection for you. So I think that's what I mean by opinionated. But I sort of want to say opinionated as a way of warning people that, like, if you adopt Isograph, like, you're adopting a way of thinking. And this has a lot of benefits. And there is going to be an incremental migration API, and everything is a React component. So if you did want to just go off and do your own thing or read data from context or whatever, you can. But the real advantages from Isograph come from adopting this way of thinking. Yeah, I think that's what I mean by opinionated.
I think that's a good way of putting it. That's what I think of when the tool says it's opinionated, is it has one way that it promotes that you think of your code or your system design or whatever aspects addressing one way of, this is the golden path or the heavily promoted way. So that's cool. I just thought it was quite interesting to explain to people. We use a lot of terms in software engineering that we don't always necessarily have a shared meaning for. Another one I wanted to really pick up on, which I think was a beautiful term, and a lot of people might not have heard before, was this network waterfall. What does that mean? For somebody that's not familiar with it, maybe hasn't worked on systems at scale, what would that mean and what should they look out for?
Yeah. So a network waterfall is essentially, it just means that you're making 2 network requests, but you're not starting the second network request until the first one has completely finished. So you might look at, let's say, a traditional banking app or an old stodgy corporation's app, and you'll see one loading state, and some stuff will pop in, and you'll see another loading state. And if you look at the network tab in your browser, you'll see that one network request completes, and then the bar for the next one starts. Now, you and I can look at this app and can say we know that both of those network requests need to occur. But because of how the app is architected, because they're shipping the org chart, the second network request doesn't start until the first one completes. And that means that data that the user cares about is shown to them later. The app is interactive later than it could be. And so there's some network requests that need to happen in serial because you are using some client state. And for example, if you have a dropdown and based upon the state of that dropdown, you'll make a network request, right? But you really shouldn't ever have multiple requests that happen one immediately after the other, because if one occurs and then therefore the next one occurs, you probably can, at least with some server support, string those together into either a single network request, both that happen in parallel, or at least do them both on the server, in which case you're missing that hop. And for users that are on 3G, 2G, far from US East 1, right? That hop can be slow. So yeah, so that's what a network waterfall is, and that's why it's the big thing that you're trying to avoid when building web apps. A lot of frameworks will try to solve network waterfalls sort of by coincidence, right? You will say, okay, I know that on the home page or on the user detail page, we fetch the blog detail. I don't know why that's our example in this. It's kind of a silly page, but therefore we tell the user detail page, okay, so why don't you prefetch this blog detail page? And now the problem is you've gone too far in the other direction, because somebody else can make an innocent looking change, make the blog conditionally shown, remove the blog, whatever. And they don't know that it was prefetched on another page. There's no sort of explicit connection between where it was fetched and where it was used. And as a result, you swing too far the other way. You overfetch. So that's sort of where network waterfalls fall in. I think network waterfalls tend to be worse than overfetching in 99% of cases, but that's not a hard and fast rule. You can't overfetch the world and expect your servers not to fall over. So
Yeah, absolutely. But if you have too much of a waterfall, it's a horrible user experience, isn't it? Nobody wants to sit there waiting for their web page to load for several seconds, or if you're on that TG example, for several minutes.
Exactly.
So by collecting this all together in Isograph and creating, as you say, this kind of graph of it, that allows you to identify what information they need, pull it together, present some way of getting that data that's separate. Does that then also make it all very testable, something that we can... I was thinking as you're talking about it, of in the past building API, I've used things like contract testing. So we know that as an API changes, as long as it continues to conform to that contract, we know it's going to work with other tools and with other systems or with clients that are using the API. Does it kind of fit in that? How do you envisage it fitting in a sort of CI/CD pipeline?
Isograph has a really good testing story in the works. With Isograph, the function that reads some data and the data that it reads are associated at build time. So the user avatar, the user detail page, which uses the user avatar, it sort of selects the user avatar and it receives something. But what it actually receives, all it cares about is that it matches the type of the user avatar. So a component that takes maybe some size prop or something like that. And this is great. It means that every single component can be tested in isolation. It's just a function from some data, and you can provide that data if you want, in any way you want. So that means that in tests, if you want the user avatar to be some sort of div with a data test ID, you can. Like, there's nothing stopping that. And Isograph makes that easy. In any other framework, you would import the user avatar component yourself. And so what you have to do, like a node or mock or require.mock or something like that. Like, it's just janky. It's like, you should look at that and think like, something is wrong with the way we are writing code right now. And nobody thinks of it on that level. Okay, so instead, because Isograph is providing all these dependencies for you, it's essentially like a data injection, dependency injection framework. You can think of it that way. You can provide different versions and thus test the user detail page basically in isolation of everything else. But we will go a little bit further than this. So you might imagine that the user avatar on desktop should be a image that's 120 by 120 pixels. On mobile, it's 60 by 60. From the user detail components page, you shouldn't care which of those avatars you get. Something else, what that something else is essentially a bundler, should make the decision for which component is actually passed in. And what's great about this is that you can write your components in a way that you don't have to change anything about the user detail page in order to get the benefit of being able to sub out different versions of this. So now we've gone from testing to executing different versions of a piece of code. And now I'm going to loop back to what you said earlier, which is privacy. If I select something like let's say the full name field, that could be a client field, which is to say it could be something on the front end that selects the first name and last name and concatenates the two. Let's say the avatar uses that. On the other hand, it could be a server field. So I could just receive the full name string. And from the avatar's perspective, it's completely agnostic as to which of the two that happens to be. And so the big thing that's going to happen maybe in 2026 is that we're going to start working on moving some of this execution of client fields to the server. And in particular, we might get a nice performance boost from executing full name on the server. If you're on a page where first and last name are immutable, but still allowing you to have those be updated in real time if you're on a page where it's mutable. Okay, that's a small benefit. Like, who cares about first and last name? But now imagine that you're calculating something like the user's credit score. Okay, what goes into a user's credit score? A whole bunch of other stuff about other users and whatever. You can't execute that on the front end, but it would be really nice to define that as a client field so you can have all the benefits of go to definition, see what is used, find all references, and so on and so forth. And heck, if you're an admin, you may want to execute that on the front end because you do want to be able to. I mean, there are just other advantages to executing on the front end, both like in terms of updating it in real time and other stuff. So there's a privacy benefit to being able to move some of this execution to the server. And then there's also another performance benefit is like, let's say you have a function with a lot of inputs and a small output. So for example, what is the top restaurant in New York? How do you calculate that? You download all the restaurants in New York, you get all their star ratings. What is a star rating? Well, it's all the ratings, and then you average the star count. Okay, like that's obviously like a ridiculous amount of work to send all that data to the front end only to extract a single ID out of that. So once again, it would be really nice to define your entire world as if it is client fields that may execute on the front end, and then some of them transparently execute on the back end for you. And all of this is possible because the connection between the data that something uses and the function that actually uses that data is known at compile time. And so anything else that matches that return type of that client field can stand in for any other client field. And a string that you get from the server matches the return type of full name executed on the client. So I know that that's like a little bit, that's a lot more than testing, but I sort of have a much bigger vision than just the ability to test a specific app in a specific configuration. It's like giving you the flexibility to like partially compile your app as much as possible, and therefore have out of the box an extremely performant app where anytime you need interactivity, you just sort of automatically get it. But if you're not using that you're not using that interactivity, you automatically opt into server execution.
Okay, this sounds really great. I can see a lot of uses for this. I'm wondering though, how does this work as you scale? So let's say we've taken the restaurant example. You've got a front end. Let's imagine that's built by a front end team. That front end is using some back end that's being built by a separate back end team. And maybe that back end team are using another service off somewhere else, which is built by a third team. Can Isograph fit all points in that chain and all interfaces? And how do you manage that integration between what might be three different code bases? Is that something that you're solving for?
I'm a monorepo maximalist, so the way I imagine Isograph used is in a large monorepo, and I haven't had a good time working in non-mono repos, so this is going to be a little bit monorepo forward. Okay.
Cool. So let's pause there, because there's a lot of misunderstanding with people of the advantages of monorepos and what we mean by that. And there's a lot of people who tell you, and I've heard this more times than I care to remember, that you can't run a project in a monorepo. It doesn't scale. Now, I think Google might disagree with that, and probably a few other big tech companies. So what do we mean by monorepo, and what do you mean by monorepo maximalist? And then let's go back to what you're going to say.
Yeah, absolutely. I have seen it scale. I think that there are unique problems with Git, but at least at Meta, there were no problems with using maybe a custom fork of Mercurial to manage everything. And from my perspective, the advantage is that if I need to change something on some backend service in order to support my front end, I can, and I can make those. I don't have to worry about versioning and so on and so forth. And I think the other part of this is that because the front end and the back end, I mean, they're effectively different artifacts, and they are actually deployed independently. You do sort of need some way for the front end to say, I am version 1.2.3, and therefore, like, let me hit backend 1.2.3. Okay, so there are certainly like implementation details that I can't give you a pithy answer for, but I've seen it work. I like the fact that I can reason about the whole code base. I can jump to definition. I can follow everything. And that's what I'm leaning into with how Isograph thinks about this problem.
So I guess we could argue that's another point where it's opinionated.
Yes. So here's what I'm thinking in terms of like a backend and a front end. Okay, so currently Isograph consumes a schema. Right now it consumes a GraphQL schema. It could just as easily consume a SQL schema, but we haven't like written the sort of the SQL adapter, I guess you would call it, quite yet. Not too hard. And the vision I have, though, is that you ingest some arbitrary set of schemas. So in particular, the SQL schema. And then you define a bunch of client fields that use, let's say, the users table and the blogs table or what have you. Okay. Now, these client fields, they live in the same code base. They live alongside your other components, but they are marked in such a way as to force them to execute on the server. And these define essentially another schema. And then you write your app against that second schema. So this second schema doesn't have access to the users table. It only has access to a field called get user or something. And that will do whatever authorization and authentication check that you intend. And as a result, you can write your app against that schema and be guaranteed, because you can't directly access users table, that any access of the user goes through something that is authorized and authenticated. But also what you don't give up is the ability to jump to definition a few times and actually find, oh, I'm using the name field, the name column on the users table. And you don't lose the ability to do some static analysis and say like, hey, when I fetch the the user detail page for user 123, well, this is exactly the fields from the database that will actually be fetched. And I'm also guaranteed that they will be, they'll have the right authorization and authentication applied. So Isograph pushes everyone to sort of be a full stack developer in a certain sense. However, of course, that's not always going to be possible. So Isograph will have to work in a way where you can just ingest arbitrary database schemas or arbitrary schemas. So that might be an open API spec, that might be a GraphQL schema, that might be, some description of some other REST endpoints. And then there's essentially something that runs on the back end and does the translation. Like I'm fetching the user detail query. Okay, that means I need these fields, and therefore I need to run this translation, full name, like concatenate these two fields. And okay, like maybe the favorite restaurant the best restaurant in New York, like off of that restaurant, we select their name and address. Okay, so that's like one request and then a follow-up request. It does all of this orchestration on the back end, and then it will send the results that the front end expects. So the way I see this is that as you adopt Isograph on the back end, you want Isograph to start. We need to meet users where they are. They have schemas that describe different things, and Isograph will do sort of that orchestration layer up front. But the more you can push that schema back closer and closer to the database, and more you can move into Isograph, more functions that you can define as client fields, the more visibility and the more traceability and so on that we can provide. So consider a full name field in a GraphQL schema. I have no idea what goes into it. That information is just not present in the schema. Or if you have like a user's field, and then there's like some filters on it, like name starts on A. I have no idea that that's a subset of all of the users. And because that information is lost, Isograph, the framework, can't in general take advantage of that and do more advanced things. But if we keep on moving that back and back towards this underlying database, well, then we get more and more advantages, and the framework will essentially try to take advantage of those as much as possible.
And some of those advantages are the things that you mentioned, like the go-to definition, do some static analysis, get some more validation in that area.
Yeah, and I think that the actual really big advantage here is that if you actually go all the way back to the SQL schema, then you could, for example, have a stateful server that knows that, hey, somebody is looking at this particular task or this set of issues, and that maps to these fields, these rows in the server. And therefore, whenever those rows change, we can just push an update to the front end, and you sort of get automatically, without any extra work, a real-time app. And that's simply impossible if you're going through something like a GraphQL schema, because that information is just not there. And yeah, so that's actually, I think, the big kahuna here.
It sounds incredibly useful, and a huge vision you've got there for Isograph. So how are you going about building this? What's it built on?
So Isograph, there's two parts to it. One is the runtime, which is currently written in TypeScript. Like I mentioned earlier, GraphQL, JavaScript, and React, they're all implementation details. So in particular, the runtime consumes a bunch of generated files, and the generated files basically are JSON data structures and imports of exported functions. Okay, that's kind of possible in a lot of other languages, and in particular, possible in Swift and Kotlin. So there's going to be another version of the runtime in those languages, at least. And the runtime, you can think of it as essentially a store that does a lot of that will keep track of the dependencies of a particular function and call a function when those dependencies have changed. This happens to re-render the component and thus keep your UI up to date. And then those generated files, they're generated by the compiler. That compiler is written in Rust. And essentially what it does is it scans the code base for these Isograph literals, parses those Isograph literals, generates a data structure that includes all of the types, so user, blog, whatever, and all of the fields available on those types. And then based upon that data structure, will generate all of the generated files. So it'll generate some TypeScript types that correspond to, like, okay, the full name field, its parameter will be a first name and last name. Yeah, that's sort of the gist of how it's all set up.
So that compiler is presumably sitting somewhere in your toolchain and running before your TypeScript compiler, for example,
Exactly.
and generating all this.
Yeah. Yep.
Cool.
Yeah.
Cool. And what made you pick Rust for that compiler?
So previously, I was on the Relay team at Meta, and Relay has a very similar structure. It's a framework for building apps that are powered by GraphQL data, and it has a Rust compiler. However, a lot of the underlying stuff about Isograph, you can think of it as like Relay with, I think, substantially better developer experience, with needing less support from the server, and with giving you a better upgrade path towards a lot of things. Um, so there's, to some extent, like, this was strongly influenced by the fact that the Relay team, the Relay compiler is written in Rust. However, I ended up on the Relay team at Meta because when I joined, I really wanted to work on a team that used Rust. So I scanned our internal GitHub tool, which is Fabricator, and just looked at PRs that touch Rust files, looked in the space tool to see where this person sat, and was sad because almost everybody was shipping who was shipping Rust code was based in the Bay Area, and I was in New York. And then a PR landed that touched the Relay compiler, and I was like, wow. So I sat down next to this person, like, I'm joining your team. It turns out they had an opening. So that's how I ended up on the team. And the reason I wanted to use Rust is because I've actually been using Rust for quite some time now. Before Relay, I worked on a framework called Smithy, which you can think of it as you write something that looks like React, but you write it in Rust. In this case, there's a procedural macro that converts what looks like XML to essentially to a function that will generate your markup for you. And I've been organizing the Rust NYC meetup for, I think, 8 years now. I'm not exactly sure the amount of time. So I've been into Rust for a long time. Okay, so that doesn't answer your actual questions. Like, why did I choose Rust? Like, why? What drew me to it? And the answer is that I think that, like, when I first read about it and I like really read about the borrow checker, like, something really clicked, because I have been trying to write code in a way that's cannot be broken without static checks breaking for a long, long time. And in particular, I want to scale myself by making it possible for other developers to move quickly without accidentally breaking code. And in various forms, I have been working on aspects of that problem. So Smithy fits really well into that. Relay fits really well into that. Isograph fits really well into that. Before that, I had worked on some React components, I guess, like mini framework for unwrapping promises in a declarative way. So it's much easier to, for example, so you don't call set state in a callback, and therefore allow your app to get into a weird state. Before that, I worked on a framework for going through a wizardy flow in a configuration driven fashion. So everything sort of builds up to this same thing. And when I learned about Rust, the borrow checker like really clicked with me. It took a few tries for me to actually learn how to use it. But like the fact that you can have only one mutable reference to a particular piece of data or many immutable references, like, that makes perfect sense. I want to guarantee that, and you simply can't in most other languages. And that is just like incredibly frustrating to me, because people break that rule all the time. They modify fields that they think, I mean, in a way like, oh, it's not actually broken. But like, the problem is not that it's not actually broken in this case. It's that you're making it impossible to enforce that this API is used correctly. And that just makes me sad, because I want to build this like set of abstractions that don't, one, get more poorly performant over time. So, okay, it needs to be a compiled language. And two, are something that you can rely upon. So the only way you can't get one in JavaScript, obviously. The only way you can get two is by really worsening performance, by making everything an immutable data structure, so that if you hand out a reference to a user, even if they modify it, either something throws or they get a new data structure or what have you. That's like a lot of overhead. And when I learned about Rust, the fact that I could write this extremely high level code but have these low level guarantees just like really, really made me excited.
So
Yeah.
am I right, Robert, in thinking then that you perhaps started in JavaScript or another kind of web development associated language and have gone from, should we say, fairly high level down the stack towards Rust, which some people would consider more of a system programming language? Cool. Interesting. I think it's a relatively rare journey, though, that people start at that and want to work down to that statically typed and kind of want to get rid of that flexibility. I came at it from the other way in that I started off doing more C programming, hated the kind of Wild West feel of that, and found C++ to be much better. And then when I saw Rust, it's like, hey, this is even nicer. You've solved a lot of the problems from C++. Cool, that's really interesting. So what has been the challenges in building a compiler in Rust then?
One of the things that we're trying to do is rewrite the compiler from being a batch compiler to an incremental compiler. And that is a long project. It's challenging. Not 100% certain that that's like strictly related to Rust. On the Rust side, to a certain extent, the borrow checker model doesn't work extremely well because this is a data structure that isn't clearly a tree. So, for example, you might have a best friend field on the user object, which is itself a user. Okay, so who owns the user object? Like, does the user go through the best friend to another user? Like, what does that mean? So really what you need to have is essentially an ID, which is the name. Okay, so everything that's in the same namespace will have a string essentially as an ID, an intern string. And as a result, if you were to try to model that in the using references, you would very, very quickly run into a problem with the borrow checker. If you were to try to model that with, let's say, reference counted pointers or something like that, basically Rust has data structures that allow you to get around this, like do some runtime borrow checking. Then it probably wouldn't be that much overhead, to be honest, but it's a little bit less clean, I think. So one way I avoided problems in the use of Rust was by having everything have these like top level data structures. So a map of all of the types and a map of all of the fields. And then every time we need one, we sort of access it. And then there is the risk that a field we expect to be there is not actually present. And so we have like a few, like not a few, we have quite a few unwraps and expects throughout the code base. But in practice, we don't see that causing panics because it has been validated beforehand. That's the kind of thing that I think like you can that it's a little bit of an inevitable trade-off, but I think you can do some clever stuff with data structures. For example, have something like a username which is unvalidated, and therefore when you try to fetch it, it will return an option. A type name, and then a validated one where you really strongly expect that it exists, and it will panic when you try to look it up if it happens not to be there. That I think is like a fairly good compromise, and it's probably a pattern that we'll move towards. But overall, I've had a lot of success using Rust for the compiler.
You mentioned that you're moving from batch to incremental. Again, for people that haven't written compiler, haven't thought about this, what do those two terms mean?
Cool. So a batch compiler is sort of what you would think about as a compiler. It starts, it reads a bunch of files, it parses a bunch of things, it has a bunch of passes, and then it generates some output. So in this case, the output is the generated file, sort of the JSON objects that we talked about earlier in the TypeScript types. And this has some advantages. One, it's really easy to reason about what's happening. Two, it looks like a regular program. And 3, it's it was fairly fast to get out. The problem with this methodology is that if you're running the compiler in watch mode, let's say, and the user makes a small change, well, you're redoing all that work from scratch. That small change might be to add or remove a field from some subcomponent. And yet we're reparsing everything and we're revalidating everything. Okay. The other problem with this is that if you're powering a language server, well, most of the time, the code is in an invalid state. You might have started to type full name, gotten halfway through, and then you hovered on avatar, right? If we have a batch compiler, well, it will encounter full N and throw up its hands and say, here's an error. And therefore, when we try to provide results for hovering on avatar, well, we won't have that data structure that describes all the types and all their fields and their descriptions. So we won't be able to say the avatar is a picture of a user. So the way an incremental compiler works, on the other hand, is essentially to try to reuse as many incremental results as possible. Okay, so that's really obvious what that means for watch mode. That means when you make a small change, you only need to do a small amount of work. And for the language server, what it means is that you don't try to do a bunch of unrelated work. So in particular, to validate, let's say, the user.avatar field, right, or to show hover information, you need to check, does the user type exist? Does it have a field named avatar? Nowhere do you need to check, does full N exist? And so therefore, if you don't ask for that, you will not get an error, and you will be able to show valid results even if the rest of the app is in a broken state. So this is challenging because having large data structures is the natural way to do a lot of things. Like, it just makes sense to have a map of all the types. And if you had told me in advance that you're not going to want that, like, it would have blown my mind. Like, of course you want that. That's how you do things. Okay, so there's sort of two problems that we've encountered when it comes to migrating from a batch compiler to an incremental compiler. First is that these large data structures are ubiquitous. And if we have a large data structure, such as the validated schema, so it takes the thing that lists all the types and all the fields, well, there's two problems. One is that if we're in an invalid state anywhere, that type will not exist. I mean, that data structure will not exist. And two, it means that if we make any change to anything unrelated, that is an input that flows into that data structure. So now that data structure is invalid and needs to be recalculated. And wouldn't you know it, creating that validated schema and writing the artifacts to disk, that's over 50% of the time that the compiler takes. So we have a hard limit, a hard cap on the amount of improvement that sort of memoizing individual functions can give us. Okay. Now there's a related problem here, which is that the way the validated schema is, the function is written, is it takes as input all of the ASTs that we have parsed for all the Isograph literals. And basically what we're doing is we're trying to memoize this function. So if we call it a second time, and we've seen these parameters before, and the fields that it reads, which is to say the inputs and the other memoized functions, are unchanged, well then the framework can prove that the output of this function will not have changed. Okay, but the problem with that is that one of the parameters is this absolutely massive array of all of the ASCs. And so as a result, this means that we're under the hood creating this hash map where the keys are arrays of every single parsed AST, right? Like, that's just really bad for memory. It's really bad for performance because you're comparing large data structures and so on and so forth. Okay, so not only do we need to not have these large data structures, we also need to not have functions that take large parameters. One, because that will invalidate everything, and two, because it's poorly performant. So instead, what we need to do is sort of get rid of these large data structures by encoding instead of by storing things on data structures, storing them as the results of memoized functions. So now, instead of checking that validated schema for whether a user exists and therefore relying on the validated schema, we just call a memoized function. It's like, does the user exist? And that relies on, okay, we need to parse the schema, like the GraphQL schema. And then we just say, is a user exist? Like we don't actually validate that like some other field is valid, or I mean, some other type is valid when we check if the user exists. And then we also need to invert our compiler. So the natural way to do things is to parse all the files, pass those files into the getValidatedSchema function, and instead the getValidatedSchema function needs to call the parseFiles function. So you had sort of like do this, pass its results to this, pass its results to this, and instead we're saying this guy asks for this guy, which asks for this guy, and so on. And that's a bit of a different way to think about things. And it's we're making progress on it. It just takes a lot of thought into like, because it's a different way to think about how to actually do things. And yeah, but like once we get through this refactor, I think we're going to be in a really good state because, yeah, it's just taking a while to get through that. So,
yeah, it sounds like a challenging problem because, as you say, normally when you think about building a compiler, you're going to start at the top and pass from the beginning to the end, where the changes you've got for an LSP, you could be halfway down a file, you could be typing in the middle of something, it could be all over the place, and you don't want to reparse everything you've done just for that small change, potentially.
exactly
Have you had
right.
any big advantages from Rust that you weren't expecting?
I think we do take advantage of Rust pretty heavily. Like the core thing, not really in the core thing. Like we're doing something fairly simple. We're doing an LL1 parser, like clearly possible in any other language, and then writing files to disk. And there's some sort of, sort of the core of the compiler is not taking advantage of Rust too much. We haven't gone multi-threaded yet, but the fact that Rust makes multi-threadedness and parallelism like safe and easily verifiable should make that a fairly easy transition. And I anticipate doing that probably sometime next year, but I don't think it's going to be too difficult. The things that we've taken advantage of Rust for, I think, are more developer experience things. And I really like procedural macros. I think that they're really fun to work with, and I think that it does make for a more pleasant coding experience. So, for example, some of the things that we do include if you have a data structure like that describes the Isograph literal and a location, like maybe a character location, 50th character. It's actually 4th line, 30th character, something like that. Well, we often need to know what are you hovering over. And that is useful for go to definition, for hover, for soon, for autocomplete, and so on. And what we've done is essentially define on every single data structure that is part of this Isograph literal. So there's the Isograph literal itself, there's sort of the selection set, there's an object field, there's scalar fields, there's arguments, and et cetera, et cetera. Define a procedural macro that allows it to say, I am on top of character 123 in this thing. Therefore, let me find the location and create this type safe data structure that says, I am hovering on the name field, which is a scalar selection, which is part of the user field, which is an object selection. And that part of thing is entirely type safe, which is to say, it's like a parent relationship, and the parent of, let's say, a scalar or object field, it can't be a scalar field. It has to be an object field or the client field itself. And the parent of let's say, an argument, it could be another argument. It could be part of an object, or it could be a field. But it can't be the client field itself, sort of the Isograph literal itself. And this allows us to do really cool things like not have panics when we calculate stuff like let's say we're on user best friend name. We need to figure out where that name field exists. It's on a user, we know that, but how do we know that? Well, it's because we check what is the best friend field, what is the best friend field, what is the name. All of that can be, it just ends up being a nice iteration where we just check the parent and then we look that up and we check the parent and so on. So that I think is something that's really cool. And we've implemented it in a way that's dumb. It just checks the first thing and checks hey, does this span exists in this first thing. Then it checks the second thing. Then it checks the third thing in the way that it's defined in the code base. But like we could do like a binary search here, and there's just one place that I'd have to change that. And now suddenly, if I'm looking for something that's at the 50th character, well, instead of checking the name and then the arguments and then the blah, 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 and then checking each field individually, I could check the middle thing and then sort of like do like a binary search. And that's especially important because most of the time we'll be selecting on the selection set. And we have, I mean, it is a vector. So it's like really obvious how to do a binary search on it. Yeah. So that's one thing I'm really excited about. Another cool thing we've done is Serde is a Rust library that makes it easy to deserialize and serialize data structures. So you might define a struct, user, name, email, right? And then you can deserialize it from JSON. And that happens in 2 steps. First, that JSON is turned into some agnostic data structure that says like, I mean, it's kind of like untyped in a certain sense. It says like, okay, I have a key and then I have a value, and that value can be anything. And then Serde will generate the code that will say like, is this random untyped data structure, does it match this user data structure? So you can go from JSON, you can go from BSON, you can go from CSV, like whatever you want. You can go from gRPC. And the thing that we've done here is we do the same thing for, they look like directives. I mean, I'm not sure exactly what to call them in Isograph, but like there are directives. So you might have like at loadable, lazy load artifact true. And then we will turn that into that agnostic data structure and use that as an input. So now we have like a whole bunch of data structures throughout the code base where you can just add a field or remove a field, and that changes the parsing behavior of Isograph as a framework. And so that like is really awesome because it really improves our velocity. We don't have to like reason about where we parse things, and we don't have to like manually encode like, oh, I don't want extra fields on here. You know, like that's actually a really annoying thing to do. Like, do you have extra fields on this data structure? Well, Serde has done that once for me. And yeah, that's another thing that we take advantage of. There was a third. Maybe those are the things that maybe the third one was Pico, the incremental incremental compilation and calculation framework. Oh, I guess another cool thing that we do is that all the strings are interned. And we use a lot of strings, and it's really easy to pass a string to the wrong location in a compiler. So essentially, every single string, when it's interned, is also wrapped in a new type. So we might have like, this is a type that we think is a type. I mean, this is a string that corresponds to a type. This is a string that corresponds to a field. This is a string that corresponds to something. And that at least gives us, now obviously the user can write something syntactically like user2. That's maybe a type that doesn't exist. So like we can't rely on that therefore existing, but we can but it can prevent us from accidentally passing user2 to where we expect a field to exist. Yeah, there's lots of cool stuff. So
yeah, it sounds like it. It sounds like you'd be very happy to talk to it for many more hours and share it. And I love the enthusiasm. So if anyone that's listening is as enthusiastic, where or are there any good examples they can see of Isograph being used?
Yeah. So there is a company, Bolt Foundry, that is all in on Isograph. And there's a few other people that are currently trying it out for side projects. And like I'm in the midst of sort of convincing more folks to adopt it. So Bolt Foundry uses it. And if you go to isograph.dev, there's a quick start on that page. And that's a great way to get started. It will help you, it will run you through building an app that uses a publicly available GraphQL API. I think it's a Star Wars API. Also on Isograph, there's a bunch of demos that you can check out on the GitHub repo. But yeah, I'd recommend folks check out isograph.dev. And there is a Discord there that they are more than welcome to join. Like we want folks to adopt it. We want folks to help out if they're enthusiastic about pushing the state of web and app development forward. I think like it's really a good time to join because there is a long and well thought out roadmap. And there are still sort of fundamental groundbreaking work to do. But there's also it's already at the point that the developer experience of using Isograph is, I think, head and shoulders better than using any other framework.
And what about if somebody wants to get involved and help support building the tool and building the compiler?
But yeah, so join the Discord. So isograph.dev/discord will give you an invite. Yeah, join, say hi, reach out. We have a whole bunch of tasks that are, good for incoming folks. I don't know why I put that in quotes, but are good first tasks. That's the phrase I was looking for. But yeah, I'm happy to pair with anybody who's sort of enthusiastic about it, and so we'll go through the compiler because it's a big code base, so there's no reason for you to hit your head against a wall for a month before getting anything done. Like, we'll work on it together. I'll have you ship some code, and then like as you build up comfort and understanding the code base, you'll be more independent. We'll be able to move fast and far together.
Awesome. That sounds great. It sounds like a really interesting project.
Thank
Great
you.
chance for anyone that wants to get involved in like a compiler or using List to get involved in, I guess, what is an open source project, and to do some very, very interesting work. Anything else that I haven't asked about, Robert, that you think people would find interesting about Isograph?
No, I mean, I think like you should give it a try. Right now, it requires a GraphQL backend, and that is a deal breaker for a lot of people. So check back in about 6-ish months. Right now, we're recording right before Halloween, and at some point in time, we will enable this working with SQL backends or arbitrary other backends. Like, the refactoring work is already done, but once that's the case, like all bets are off. Like, it's going to be extremely easy to use in a lot of situations.
Maybe if somebody's passionate about SQL, they could volunteer to help out and accelerate that roadmap as well, I guess.
Yeah, I'd love that.
Okay, cool. You mentioned a bunch of the links. We'll get them off you afterwards and stick them in the show notes if anyone wants to find out. Thanks very much, Robert. That was really interesting to hear about.
Cool. Thank you, John. This was a lot of fun.
I hope you enjoyed that episode of Coding Chats. If you did, please like and subscribe. And feel free to check out these other videos on a similar topic.